Good morning, guys. So today we are going to move on to the last and final section in our Chapter 8 chapter on factoring. And we are going to talk about factoring by grouping and also making sure polynomials are factored completely. So both of these things we've actually talked about a little bit. Factoring completely usually means that it's factored as far as it possibly can. There's no GCF that can still be taken out. It's as simplified as it can possibly be, which means that each factor is a prime. It can no longer be divided or broken down by anything else. And one of those methods that we're going to do today is called factoring by grouping, which is actually the second portion of the AC method that we already did. So it's kind of nice because it's something very similar to something that you've already done. So starting out, the vocabulary that we're going to go over here, first thing, like I just mentioned, is factoring a common monomial from pairs of terms, and then looking for a common binomial factor is called factoring by grouping, and that's really the second half of AC method. A polynomial of two or more terms is prime if it cannot be written as the product of polynomials of lesser degree using only integer coefficients and constants, and if the only common factors are 1 and -1. So for example, if you think of the term prime with just numbers, if you have 5, that's a prime number, right? Because you can't divide it by anything other than itself and a 1. So for example, if you had the number, let's say 18, and you wanted to break it down into its simplified form of factors to make it prime, you would, let's say you do 2 times 9, and then 9 can be broken down times 3. So you would have 2 times 3 times 3. That would be like your prime factorization. And that just means the number is broken down into the smallest pieces that could be used to multiply it back together. So the first thing we're going to do, for example 1, is factor out a common binomial. Now these are already kind of set up where this piece is already matching up, this binomial here. So all you're really going to do is take these two terms here that were factored out. Those are basically just GCFs that were already factored out. And you're going to put those two together in one parenthesis. And then the one that's doubled goes in the second parenthesis like that. Now, anytime you still have an exponent on your x, you kind of have to double check it because sometimes you can still do a little more factoring with it. It can be broken down a little bit more. But even though x squared could be broken down, there's a 5 there, which is a prime number, and 3 is also a prime number, so there's nothing else you're going to be able to do with that. Now, B, on first glance, these two look very similar, but you'll notice that one is y minus 5 and the other is 5 minus y. So they're actually different. So if I were going to rewrite this and I wanted to switch these to make them look more like the other one, then I would really have negative y plus 5, because you remember the sign in front of the number is always what's going to go with that number. So now, if I want to divide that negative out and put it on my 7y, that would make this y positive, and then that 5 would become a negative. And now, my two parentheses here are the same. So they have to be the same order as well in order to finish up the factorization. So now it's just like the end of AC method where you take those two GCFs and you put those together in one parenthesis. And then you take that repeated factor and you write that in your other parenthesis. And those would be your two factors. So factoring by grouping, like I said, it's sort of the same second half of AC method. But there's a very important piece, is that it must be in standard form first before you attempt to do that AC method. So if we take a look at example A, we have m cubed, then plus 7m squared, then minus 2m, then minus the 14. So it's in standard form because it starts out with the highest exponent and it works its way down in descending order all the way till you get to a constant. So then you're going to group your first two terms together. and you're going to take a GCF out of those, and then you're going to group your second two terms together and take your GCF out of those, just like we do with AC method. So what can I divide these two terms by? What would be my GCF? Well, I can't take out a number because there's a 7, but it's only in one of the terms, but they both have some version of an m. So whenever they both have the same variable, whichever variable is smaller can be taken out as the GCF because they can both be divided by whatever one is smaller. So in this case, that would actually be m squared. Now m cubed divided by m squared would leave you with one more m. And 7m squared divided by m squared would just leave you with 7 because the m squareds would basically cancel out. Now, if you want to check your work, you could just distribute, right? So if I was to do m squared times m, I want to make sure I get back to this m cubed. If I was to do m squared times 7, I want to make sure I can get back to the 7m squared. So now when we go to the second half, we want to look for a GCF of these two terms. And 2 and 14 are both divisible by 2. And if you remember what I had told you back when we did AC method is whenever sign is on that number there, that third number has to go out on the GCF. So we're really going to take out a -2 for that GCF. So -2m divided by -2 leaves me with positive m. And then -14 divided by -2 leaves me with positive 7. So now we're going to take those two GCFs, which are m squared minus 2. That makes our first factor. And then our second factor, as long as these two binomials are the same, which they are, then that repeated binomial makes our second factor. Now, m squared, if there's still an exponent in one of your factors, you need to double check it because if this was m squared minus like 4 or 9 or some other perfect square, then we could do that pattern that we just learned in the last 2 days. But 2 is not a perfect square, so there's nothing else we can do. So our final answer for this one would be just those two factors there. All right, now when we take a look at the next example, going back to what I said up top here, it must be in standard form first. So we have n cubed, but then we would have to put it in order where the 6n squared comes next, then the 5n, and then the 30. Now it's in standard form. So now we can group together those first two terms, group together the second two terms. So the first two terms, what is my GCF there? Well, there's no number that can come out because only one of the terms has a number other than 1. But we have an n cubed and an n squared. So when they have the same variable, whichever one's smaller is the GCF. So n squared would be your GCF. And then you divide each of those terms by that GCF. So n cubed divided by n squared leaves you with n. And 6n squared divided by n squared, the n squareds would cancel, and you're just going to have plus 6. Now on the second half here, 5n and 30, they're both divisible by 5, and it's a positive because that's the sign that's in front of our 5n. And 5n divided by 5 leaves me with n, and 30 divided by 5 leaves me with positive 6. So the good thing about this is when these match up, it's like you kind of know that you did it correct. It's sort of like a little verification in the middle of the problem. It's like, oh yeah, you're on the right track. So now I take my two GCFs, which are n squared plus 5. That makes up one of my factors. The repeated binomial there is my second factor, n plus 6. Now, n plus 6 is simplified as far as it can go because we just have a single variable there. N squared plus 5, we need to double check it because it has an exponent. N squared is a perfect square, but 5 is not a perfect square, plus this is a plus sign, not a minus sign, so we can't use that pattern of difference of two squares. So we're just going to have to stop right there. All right, so let's do a couple practice problems similar to what we just went over. So for the first example here, we see that this x minus 8 is already the same. So then we're going to take our two GCFs, which are 11x plus 3. Those come together to be our first factor. And then that repeated binomial would be the second factor, which is just x minus 8. And that's it. All right, now the next problem does not have the binomials already factored out, so we have to do that step. So this is where we're going to look for those GCFs. Now, making sure it's in standard form first, which this one is. We have our 9x cubed, followed by our x squared, followed by our x, followed by our constant. So we group together the first two terms and then the second two terms. So the first two terms, we're going to divide out a common term, greatest common factor, right? They both are divisible by 9, so we can take out a 9. They both have some version of an x, so whichever one is smaller is part of that GCF, so 9x squared. What is left when you divide 9x squared out of each of those? So 9x cubed divided by 9x squared leaves you with just a single x. And 9x squared divided by another 9x squared would just be a 1. Now the second half, we have both of these numbers are divisible by 7. And remember, because this is a negative, it's going to have to be a negative 7 for that GCF. So when we divide each of those by negative 7, we're going to get positive x plus 1. Now that's great news because now both of these binomials are the same. So now we can group our two GCFs together, which is 9x squared minus 7. That will be one of our factors. And then that repeated binomial, x plus 1, will be written down once to make our second factor. Now x plus 1 is simplified as far as it can go because it's just a single x. 9x squared, we have to kind of double check though because we do have that exponent. Now 9 is a perfect square, x is a perfect square here because it's x squared. We have a minus sign, but 7 is not a perfect square, so we can't break this down any further. If it was like 9x squared minus 4, then we would be able to break that down a little bit more, but we can't because 7 is not a perfect square. So that would be our final factored answer for number 2. Okay, and then number 3. Now this one's a little tricky because we have x's and y's, and a lot of people are not familiar with doing those types of problems, and we haven't done one like that yet. So first thing we want to do is put it in order. So you're looking for that highest exponent we see, which is still that 10x cubed. Then I want to look for any x squares, and I see minus 35x squared. Now the next term I'd be looking for is a single x, and I do have a single x, it just happens to have a y with it, which is fine. And then I would have this plus 21y here at the end. So even if you have multiple variables, you still want to put it in standard form, starting with your highest exponent, working your way down. So now we're going to group those first two together, group the second two together. So of those first two terms, the 10 and the 35, our GCF there would be 5. And then because they're both some version of an x, the smaller of the two is x squared, so 5x squared is the GCF. Now when we divide each of those terms by 5x squared, 10 divided by 5 is 2, and x cubed divided by x squared would leave me with an extra x there. Then negative 35 divided by 5 is negative 7, and then the x squared divided by the x squared would just cancel out. Now in the second half here, I have my negative here in front of my 6. 6 and 21 are both divisible by 3, and because of that negative, it has to be a negative 3. Now what else do they both have in common? Well, they both have a y. So the y can also come out as part of that GCF. So now what is negative 6xy divided by negative 3y? Well, negative 6 divided by negative 3 is positive 2. The y's would cancel if I were dividing, and I would still have an x there. Then 21 divided by negative 3 would be negative 7, and of course the y's would divide, they would cancel. So now, notice I ended up with the same binomial factor here that's repeated. So I'm going to put my GCFs together, 5x squared minus 3y, and my second factor is going to be 2x minus 7. And even though I still have an x squared, I can't break it down any further because 5 is not a perfect square, and 3 is not a perfect square, and y doesn't have a square either, so I'd have to just leave it. Okay, so now example 3, solving polynomial equations. So again, whenever you have that equal sign and you're doing anything with factoring, you really want it to equal 0. So anything that's not equal to 0, we're going to rearrange it and get it into that standard form, making it equal 0. So this 105x, we're going to subtract it over to the other side. So now I would have 7x cubed plus 14x squared minus 105x equals 0. So first step, get it equal to 0. Now, the second thing you should always do with factoring is look for a GCF. If you can take out a GCF of the entire polynomial, all the terms have to be able to be divided by that GCF, then you take it out. So 7, 14, and 105 are divisible by 7. So, and the other thing that you'll notice is they all have some version of an x. We have an x cubed, an x squared, and just an x. So I'm going to take out a GCF of 7x, and then that's going to leave me with x squared. 14x squared divided by 7x is going to be plus 2x, and 105 divided by 7x is going to be 15, and it's going to be a minus still. And then I have my equal 0. So now this part in here is just a simple factoring problem like we did before spring break. So you break up that x squared into the two parentheses, x and x. Then what two numbers are going to multiply to get the 15 and subtract to get the 2? So that's going to be your 5 and your 3. And it's a positive 5 and a negative 3. Now, because we're solving here, every factor that has a variable needs to be set equal to 0 and then solved. So for this one, we actually have 1, 2, 3 factors that we need to set equal to 0 and solve. And that makes sense because the highest exponent in our problem was a cube, x to the third. So usually that's how many solutions you're going to have. Not always, there are exceptions, but generally speaking. So the first one, if I do 7x equals 0, and I divide by 7, I get x equals 0. That's one of my 3 solutions. Then I'm going to do x plus 5 equals 0. Subtract 5 to get the x by itself. X equals negative 5. And then I do the third one, in this case, which would be x minus 3 equals 0. So I add 3, and I get x equals 3 as my third solution. So there's 3 solutions for that problem. All right, so if we take a look at number 5, this time it's already equal to 0, which is great. So we're going to start out by looking for a GCF. So 2, 8, and 42 are all divisible by 2. And they all have some version of a c, the smallest one being just that single c. So we're going to divide out a GCF of 2c. So 2c cubed divided by 2c just leaves you with c squared. 8c squared divided by 2c is going to be positive 4c. 42c divided by 2c is going to be 21, and it's going to be a minus sign still. Now that we no longer have a coefficient in front of that c squared, we can break it up into the basic factoring like we did before spring break. So c and c, and then what two numbers multiply to get 21. You can look them up on your factor sheet and subtract to get 4. And we know that it's 7 and 3. So now I have 3 factors here. I have 2c, which I'm going to equal to 0. I have c plus 7, which I need to equal to 0, and c minus 3, which I need to equal to 0. And then I would solve all 3 of them and get my 3 solutions. So divide by 2. 0 divided by anything is still 0. That's one solution. Then subtract 7. So c would equal negative 7. And then the third one, I'm going to add 3. And c is going to equal 3. All right, and now let's do 6 and 7. So for number 6, again, it's already equal to 0, which is huge. So that saves us the trouble of trying to get it equal to 0. So we want to look for a GCF. So I'm going to guess that these are all divisible by 4, and they all have some version of an x, so I can divide out 4x, and that would be my GCF. When I divide out 4x from all 3 terms, I'm left with x squared plus 12x plus 36, right? So now I have a simple quadratic trinomial in here. It starts with x squared, so right away I can factor into x and x. What numbers multiply to get 36 and add up to get 12? So what would that be? 6 and 6. So now I have 3 factors that need to be solved. So 4x, I'm going to equal that to 0. X plus 6, which I'm also going to equal to 0. But the other one is the same thing, so I really don't need to do it again, because if you were to factor this, you could have also used the pattern that we were just working on yesterday. So you could have, I'm just going to write over here to the side, wrote 4x times x plus 6 squared equals 0, and then you would only know to do it once. All right, so we're going to divide by 4 here. X equals 0 is one of our solutions. Then subtract 6. This is our other solution. And technically, we still do have a third solution. It's just another -6, so we don't have to really bother finding it. And then finally, the last problem, we have to get this one equal to 0 first. So I'm going to subtract this 20r squared over to the other side. Make sure you put it in between the cube and the single r, because it has to be in standard form. Now we can figure out our GCF is 5r, because all those numbers are divisible by 5, and they all have some version of an r, the smallest one just being the single r. So 5r cubed divided by 5r is going to leave you with r squared. Negative 20r squared divided by 5r is negative 4r. And 15r divided by 5r is going to be 3. And then you would want to see if you can finish factoring that. So r and r, 3 and 1, and they're both going to be negative signs. Then you set each of your factors equal to 0, and then you're going to solve each one. Oops. So dividing by 5, r equals 0, that's one solution. R equals 3 is the other solution. And r equals 1 is my third solution. And since it was a cube problem, that usually indicates that there's going to be 3 solutions. All right, so I'm going to follow this up with a homework assignment on the quizzes. It just seems to be the best way. It grades it for you. You could see how well you did. And it's very easy for me to log on and get everybody's in one spot. So that seems to be working. We're going to continue with that. Tomorrow, we will do a little bit more practice and review on this 8.8 section. And then we will have a little quiz assignment. That will be your assignment on Friday. Okay? Have a great day, guys, and enjoy.